Next question is 1.136. A small body A starts sliding from height h down an inclined groove passing through a half circle of radius h by 2. So in this problem a diagram is given that this is the shape of given system like this. Okay, this height is h and radius of this groove is h by 2. This radius is h by 2. Okay. Now the question is, assuming that friction is negligible, find the velocity of the body at highest point of its trajectory after breaking of the groove. Okay. So let's assume that when this object A of mass m rolls down from this height and reaches to this point, okay, this point which is making an angle theta with the horizontal, it breaks the contact, okay, at this angle. Now we have to find out its velocity when it becomes completely horizontal. Okay, so for that, first of all, we need to apply the concept of conservation of energy. As external forces like friction or anything are negligible, so we can apply conservation of energy concept. Okay, so this is our reference line. So first height is h, second height would be, this portion is, radius is h by 2, so it is h by 2 sine theta. So net height is h by 2 plus h by 2 sine theta. Okay, and let's assume that velocity at this point is v. Okay, and mass of object is m, so we can apply conservation of energy. So initial energy is a potential energy at this point. So initial energy is m into g into height of the object. That would be equals to potential energy plus kinetic energy at this point. So potential energy is mg h by 2 1 plus sine theta plus half m v square. Okay, so we can modify this equation if we want to correct it. So we can write mv or m will get cancelled out from this expression. So we can write v square is equals to 2gh plus or minus gh into 1 plus sine theta. We just shift this term on right side. So v square is equals to gh minus gh sine theta. I will open this bracket. Okay, so this is our first equation. Second, if we'll calculate net force working on this point, because it is performing circular motion. Okay, so net reaction force from this surface will be equals to centrifugal force working on this object. Okay, so its weight is mg. So there will be one component due to this weight, that is mg sine theta. There will be a normal reaction from this surface. So we can apply concept of circular motion, that mg sine theta plus normal reaction is equals to mv square upon r, and r is h by 2 here for this groove. Okay, now if this object A breaks off the contact, it means there will be no normal reaction, n is equals to 0. Okay, so from here we can write v square is equals to gh over 2 sine theta. So now we have two equations related to v square. Okay, so we can equate them, equation number 1 and equation number 2. Okay, So if you equate, then you will get GH minus GH sine theta from first one is equals to GH over 2 sine theta. So this GH term will get cancelled out, and from here we'll get T 3 by 2 sine theta is equals to 1. This implies sine theta is equals to 2 by 3. Okay, this is our first result. Now from this equation, if we'll have sine theta is 2 by 3, then we can calculate velocity of break off when this object break off this point. So velocity is equals to, from equation number 2, is under root GH over 3. Okay, this is a very important result. Now see, there is very interesting phenomena would take place after this object breaks off. Okay, this angle is theta, so it is alternate angle 90 minus theta. Now if we'll redraw this situation here, then you can see this object will perform a projectile motion. So this object will perform a projectile motion by making angle 90 minus theta with the horizontal, and this is its initial velocity which we already calculated. Okay. Now if we'll follow the path of this object, then at maximum height there will be no vertical velocity component, only component will be there, that is horizontal component Vx. Okay, and from here you can see Vx is equals to V sine 90 cos 90 minus theta, because horizontal component, which is equals to sine theta. So we can say the horizontal velocity component Vx is equals to V sine theta. Okay, V is root GH upon 3 and sine theta is 2 over 3. So we can put a root GH over 3 into 2 over 3. So Vx is 2 by 3 root GH upon 3. This is our final answer for this question.